Good morning, one and all. Myself Bhavani from Civil Department. In the last class, we have already studied about what is meant by endogenous hazard and what is meant by earthquakes, where do that occur, and which region that are going to be occurred. We already studied about that. But when we are going to measure these earthquakes, what are the equipment or what are the procedures we are going to follow? That one we are going to study in this class. That is a measurement of the earthquakes. In this one, how we are going to measure these earthquakes means we are having so many scales and also instruments that will access this magnitude, intensity and effect of the earthquakes. Why? Because in the olden days, very small, very low equipment will be there, and now there are so many measurement of earthquakes we are going to be following nowadays. And when the technology is developed, we are going to be developed our overall instrumentation also. So here I am going to tell you each and every measurement of this earthquakes here. Major primary tools and also scales that are used for the measurement of earthquakes. In that one, first one is seismographs and also seismometers. And what are these seismographs and seismometers means? Mainly these seismometers, these are the instruments that will detect and also record the vibrations of the seismic waves. Mainly these seismic waves that can be generated during the earthquake, that is called as the seismometers. It is nothing but the instrument that detect and also record the earthquake. And if in that area any earthquake is going to be occur means automatically these seismometers will just note down that area, means what magnitude that occur and how much intensity, at what intensity it occur, what are the effect that are going to be noted in this seismometers. Means effect it will not know, but magnitude and intensity we can see in this seismometers. And mainly these instruments, what data they will provide means it will provide the crucial data on the time, location and the strength of the seismic event, that is nothing but magnitude, intensity of the earthquakes that are going to be occurred at a specific area. And mainly how these seismograph or seismometers that are going to be, means how they work means, here you can see these mainly these seismograph, it consists of the pendulum. This is the pendulum. Here you can see this one, and this seismograph, it is consist of the mass nothing but pendulum that is suspended from the fixed base. Means this pendulum will be fixed at the fixed base. Then any earthquake is going to be occurred at some specific region means when that ground shakes means automatically that instrument base will get moves. At that time this pendulum remains stationary, means it remains stationary due to the inertia, and there will be only relative motion between the mass and also base. Due to this mass and base, due to this base, it is automatically recorded the electronically or mechanically. This will produce the seismogram. Here you can see, if this is your instrument, when on the level of the earth crust these seismometer if we are going to install means, then any earthquakes is occurred means automatically these here you can see this weight will stay only, means it cannot move upside and downside. It will just that will be mainly it will be look like that only. And here base will be, here you can base set into the ground. Mainly this equipment we are going to set into the ground. After setting out this instrument, when any earthquake is occur means its ground, means its base will get moves. At that time, this is the drum. This is nothing but the rotating paper drum. When this rotating paper drum will be there, this one is the pendulum, and here you can see this one is the pen. And if according to the base moving also, we are going to record this. Just this pen will get record on this rotate paper will be there on that drum. According to that base moves also, means according to that recorded vibrations also, vibrations will we come to know at that time, means that pen will automatically draws the line, means it how that base is moving at the time of earthquakes. It will note down everything, means in this direction it will move, in the clockwise direction it will move, means it is just here you can see these lines, no, this is nothing but the recording vibrations, means at how much magnitude it is occurred, we can easily know because of this rotating paper drum. Okay. Next one is after seismometers. Next one is magnitude scales. In this magnitude scales, mainly it will qualify the energy released by the earthquake. Means we can easily know the magnitude of that earthquake here. And what are the main important common magnitude scales we are going to observe in this generation? Means first one is Richter scale. Mainly this Richter scale it is developed in the year of 1935. It is developed by Charles F. Richter. And what works this Richter scale is going to do means it will measure the amplitude of the seismic waves. Means it is nothing but the logarithmic scale which having the overall whole number that will represent the tenfold increase of the wave amplitude, and approximately it will almost record the 31.6 times more energy release also it will note down. And this Richter scale is very much known to the people. Why? Because it is less commonly used for the large earthquakes. It is widely known, but when any very massive earthquake is going to be occurred, means it cannot be used at that time. Okay, normal earthquakes which having a magnitude less than 5, we can use this one also. This Richter scale we can use, but it will almost it will means recorded approximately 31.6 times more energy release will be there. Okay, here you can see this is the Richter scale. This Richter scale, when any means automatically this one is note down the magnitude of the earthquakes when they occurred here. This one is the instrumental. If any earthquake is occurring at that time, means just they will take this Richter scale there and they will just on these buttons, means on this button. After that one, here you can see the pen. This pen automatically draws the overall magnitude on this paper drum. Okay, here you can see the magnitude. Here you can see the lines also. And here how we can measure this means if it is strong or whether it is moderate, very light earthquake it is, means here you can see this one is the earthquake magnitude scale. If any Richter scale is we are going to use, means it will just note down like this only. Firstly, this one is 1, means it's when the earthquake magnitude is 1, means it is very micro one, means just some shaken, some normal shaken of the earth will be there. Next one is 2 to 3, it will be called as the minor earthquakes. 2 to 3 it will be called as minor, very minor earthquakes, means no property loss will be there, means just nothing will be there, just there will be shaken of the some earth will be there, or some small things will be there, that's it. And next one is 4.0 magnitude, it is called as the light magnitude of the earthquake, Means this type of magnitude earthquake, it is nothing but the light earthquake. Means at that time just things will fall down on the ground. Means like that it will be there. Next one is moderate earthquake. What is the magnitude of that one is 5. At that time overall our house will get shaken. Here you can see with the picture here they already show here. Means there will be just shaken of the houses will be there in a moderate earthquakes. Next is strong. That strong magnitude range is 6. 6 magnitude means, see here there will be so much shaken of that house, and some columns and also beams also they shaken at that magnitude earthquake. And next one is 7. 7 nothing but it is a very major earthquake. 7 magnitude means it is a very strong earthquakes. Means overall your house will get fall down. Here you can see the picture. Next one is 8, 9, 10. That we called as the great earthquakes. Why? Because 7 only it is a very big earthquake. Why? Because overall property loss will be there. So much human loss will also be there. 8, 9, 10 it is nothing but the great earthquake. Why? Because at that magnitude there will be so much disturbance to the overall that region. Means property loss will be there, ecosystem loss will be there, and the human loss will be there. So much infrastructure we are going to lose at that time, at that magnitude means 8, 9, 10 magnitude. Okay, this one is the how this Richter scale will going to measure. Here you can see in this picture. In that one only, in that magnitude scale only, another one is moment magnitude scale. And what they will do in this moment magnitude scale means, this one is very much accepted scale for measuring the earthquake magnitude here after the Richter scale. Why? Because in this Richter scale we are going to just use for the normal minor earthquakes, but this moment magnitude scale we can observe for the major earthquakes also, major one. That why? Because it mainly calculates the seismic moments, which is the product of the fault area, and mainly these when these there will be rigidity of the rocks and average slip on the fault will be there. Mainly it will also provide the accurate measure of the earthquake's total energy release also, especially for the large events. Richter scale we are going to use for up to some normal magnitude earthquakes, but this moment magnitude scale we can just use for the large earthquakes also, which are having a magnitude of 6 to 7, and more than that also we can go for this moment magnitude scale. What we can see in this graph means, this one is the what are the type of earthquakes that occur overall means world range. Here they show the picture here. Why? Because here is the magnitude and here is the energy released. Why I am showing this one means, in the moment magnitude scale we are going to observe both the magnitude and also the energy release here. This is the energy released at that time, and this is the graph, nothing, this x-axis is the graph, nothing but number of earthquakes per year overall worldwide, this one. Here you can see, and when these 2 magnitude occurred means almost 1 crore of the earthquakes is occurred, means worldwide, not only in some area, worldwide this much of the earthquakes are occurred per year. And how much energy it released means only 58 kg energy get released, means equivalent of, means these energy released, it is nothing but equivalent of this explosives also. Okay, and the next one is here you can see at nearer to the 4 point, that is minor earthquakes. Nearer to this minor earthquakes, which are very much felt by the humans, are almost 12,000, And at that time, what is the energy that get released? It means 56,000 kg of energy, or 4 million pounds. It'll be nothing but what? Pounds here. Okay. Almost 4 million pounds of energy get released at that time. Next one is light earthquake. In that light earthquake, what we are going to observe? Some property damage we can observe. At that time, 2000 earthquakes per year are happen, and average tornadoes also are going to happen, and almost its energy is 4 million only. Next one is moderate earthquakes. Property damage will be there, and this type of earthquake means at a 6 magnitude earthquake is occurred in 1834, that is in New York. Almost 200 to 2000 of the earthquake occur at that time, which releasing the energy of 123 million pounds here. Next one is magnitude at 6 to 7, that is a strong magnitude. Means there will be so much loss of the life will be there. This occurred in 1994, 95, 89 also. Means here they already keep the regions also at Japan, Caliph, at that area. Means almost 20 earthquakes per year at that time happen, which almost releasing the energy of 1.8 trillion kgs of energy they released at that time. Next one is a 7 to 8 magnitude, that is major earthquake or severe ecosystem impact. There will be so much large loss of life will be there, and thus that occurred in San Francisco. This, and also some of due to this atomic bomb explosions also these earthquakes are going to be happen. Okay. Why? Because here this line, it is nothing but the energy equivalent to the explosives. Means these are the explosives or volcanic eruptions, and these are the earthquakes. Notable earthquakes here we are going to see. And in this 7 to 8 magnitude in San Francisco, this earthquake is occurred. That is mostly equivalent to the Mount St. Helens eruption. Means that is equivalent to the volcanic eruption. Okay. At that time, how much energy get released? Means 123 billion pounds of energy that get released at that time. And 8 to 9 magnitude, that is nothing but the very great earthquake. There will be total destruction and also massive loss of life will be there at that area, and that happened in Japan, Alaska, and that is equivalent to the Krakatoa and volcanic eruption. Almost it released 4 trillion pounds of energy also. And 9 to 10 magnitude, only we can see here in Chile in year 1968 it occurred. And how much energy it will release? Means 123 trillion pounds of energy it will get released. Likewise, here you can see this moment magnitude scale. Likewise, we are going to measure this moment, this one magnitude scale we are going to measure overall from the rigidity of the rocks, and how this due to this faults, and also how much energy released at that time when any earthquakes are happen, especially for the large earthquakes. We can see in this one. They will relate to this one, and we can easily understand how this moment magnitude is going to be occur. Next one is intensity scales, and in this third one, this one after this magnitude scale and also seismic meters. Next one is intensity scales. In this intensity scales, what we are going to measure means, here we are going to measure the effects and severity of the earthquakes we are going to measure, which is felt by the people and observed in the environment and also the infrastructures. Okay, due to this effects and severity of the earthquakes followed by this environment and also the infrastructure, we are going to study in this intensity scales. Okay, in this intensity scales, first one is modified Mercalli intensity scale. And what we are going to measure in this one means it will only access to the impact of the earth on the earth surface or on the people or on the infrastructures also. Mainly how we are going to study this scale means it ranges from Roman number 1 to Roman number 7 here. And here if one earthquake we are going to get means that is nothing but the not felt earthquake. And 7 at the 7 range means it is the total destruction of that area where this earthquake is going to be occur. And unlike any magnitude scales, why? Because in magnitude we are going to measure due to the magnitude, means how much due to how much magnitude these earthquakes occurred and how much energy it released. Here we cannot study that one. In this one we are going to study about the subjective, and this can vary based upon the location and also building types also. Here it is the modified Mercalli intensity scale of 1931. In this one, here you can see first one means from Roman number 1 to 7. From Roman number 1, that is nothing but not felt here. Its name is intensity name is not felt. And what is the description of this intensity is it is not felt under any conditions. Means just unknowingly, means people also they don't know if any earthquake is occurred according to this intensity 1. Okay. Next one is weak. Roman number 2 is nothing but the weak, and also 3 also weak. In this Roman number 2 and 3, what we are going to what we are going to see means mainly these type of earthquake it felt by the few people, very few people they felt this one. Mainly when some people they will be living the upper floors of the building, no, they just felt something, means some shaking of the earth. They just notable, that can be notable by very few people here. Why? Because in this one standing motor cars may rock slightly and vibrations will be just similar to the passing of the trucks. So it will be felt by very few people. Okay. Next one is a light one, and mainly it will be felt by the indoor people and also outdoors of the people. Some will be inside of the houses, no, some will be outside of the houses, and we can easily just predict, means earthquake is going to be happen like that. And at night some of the doors will get disturbed and there will be cracks on the walls we can see, and there will be sensation of any heavy truck striking the building, like that we can notice. Next one is moderate, and in this moderate one it will be felt by everyone, means there will be awakening by the dishes, windows broken, and unstable of objects, there will be overturned, like that we can easily felt this one. Next one is strong one. In this strong one it will be felt by all, and many or they will be frightened. Why? Because heavy furniture also it get moved, and very few intensities of the plastering occur. Fallen of the plastering is going to be occur at that time. And next one is very strong. In this very strong there will be negligible damage to the buildings, means there will be slight to moderate buildings, they will get somewhat destructed. If badly constructed, means without proper foundation they will build that type of buildings, in this very strong intensity they will just fallen. Why? Because they are poorly built and badly designed also, they will get destructed when this earthquakes is happened. Next one is severe. In this severe one there will be slight damage we can see in the designed structures, considerable damage to the ordinary buildings, very partial collapsing of the buildings will be there, and damage will be there for the poorly built structures, and there will be change in the well water, and where people driving motor cars or get disturbed also at this intensity. Next one is violent one, that is ninth one. In this one, there will be so much considerable damage to the designed structures, and well designed frame structures get disrupted, and partial collapsing we can see, and liquefaction occur, and underground pipes that can broken at that time. And sorry, we are having 12 intensity scale readings here. Just now I told 7, sorry for that one. And here we are having 12. Next one is extreme. In this extreme, very built wooden structure get destroyed, and most of the masonry and frame structures will they get destroyed with them. Good foundations also they get destroyed, and rails are bent, landslides are considerable from the river banks. These are all we can see. Next one is very extreme, and 12th one is also very extreme. Here we can see the total damage of the buildings, people, ecosystem, and overall roads get disrupted, and underground water facility will get disturbed, and railings will get disturbed, and also overall this seismic waves can be seen on the ground surface also. These are all nothing but the Mercalli intensity scale. By this only this can be designed. Means if any intensity scale we are going to design, means by using this one only we can just predict this one. And coming to the next one, that is peak ground acceleration. In this peak ground acceleration, it will just measure the maximum acceleration of the ground when this earthquake is going to be occurred. Why? Because it will express it as the fraction of the acceleration due to gravity. By using this acceleration due to gravity only, it will just accelerate the overall ground of that area where this earthquake is going to be occurred. It is nothing but a very crucial, very important parameter of the earthquake engineering and also designing structure to withstand this seismic forces or seismic waves also. Here you are seeing this picture now. Like this graph, we are come to know the peak ground acceleration. Means in this area how it will look like. Means here you can see if this this blue color, this 4 is less than ms less than 5, means at that area that acceleration of the ground will be like this. We are going to measure according to the acceleration due to gravity of any type of earthquakes which is occurring on the ground surface. That's why it is called as the peak ground acceleration here. Next one is earthquake early warning system. And in this one, if it is nothing but the using of the network of seismometers. These seismometer, what they will do means, firstly, those are detect the initial seismic waves, nothing but the P waves. Here you can see these P waves is called as the initial seismic waves, and these P waves, what they will do means, they will automatically provide alerts before the earthquake is going to be occur. Why? Because before the arrival of the more damaging waves, means very heavy seismic waves are going to be occur. Before that one, these damaging waves are going to be present. That is called as the S waves or surface waves. First, these P waves are the initial seismic waves. Next will be the S waves or surface wave. These P waves will just alert to the S waves here. This system, this can give the seconds to minutes of the warning to the people that are present in that area, and automatically Due to these waves that will go to the sensors, and also they will just alert to the earthquake center also, and they will take protective actions how to just eradicate these earthquakes, or how to protect the people from that region also. They will come to know due to these P waves and also S waves. They will just provide the alerts to that overall earthquake alert center also. They will just evacuate the people who are present at that area. This is about the earthquake early warning systems here. Okay, that's all about the measurement of earthquakes here. These are the references books. You can, if any doubts, you can refer this one. Thank you everyone.
Like, share and subscribe. Hit the bell icon for more updates.